Okay, today I'm going to be explaining the topic of gear ratios. So first picture that we had two gears, one at 10 teeth, the other one at 30 teeth. What happens at this intersection here is it's going to look kind of like this. And what this setup makes happen is that every gap here has to line up with the tooth here, and every gap on this side, like this, has to line up with the tooth here. So that every tooth that passes through this point on one side, let's say it was 10 teeth pass through this side, that means that 10 teeth also have to pass through on the other side. If you're looking at the total revolution, 10 teeth would be the whole revolution of the 10 tooth gear here, but it would only be a third of the revolution of that 30 tooth gear. These teeth will rotate in the same time, so if the 10 tooth gear is rotating at 1 rotation per minute, the 30 tooth gear is only going at a third of a rotation per minute. So you can decrease the speed you're spinning at. What you could also do is put these two gears backwards. So you could have the 30 tooth gear, the 10 tooth gear like this, and you're driving this one, and this one's being pushed. So instead of the 1 to 3 gear ratio, you now have a 3 to 1. And what this will do is it will increase the speed, because every 1 rotation per minute of the 30 tooth gear will lead to 3 rotations per minute of the small tooth gear. So gears are a great way for controlling the speed, because you can either go up or down, and depending what gear ratio you have, you can choose the magnitude of this increase or decrease. And another thing that gears are good at is controlling torque. So we know that torque is equal to the force times the radius. And if you look at the tangential teeth, they line up sort of like this, and the force that acts here, from Newton's laws, we know that the force on one will be equal to the force on the other. So the force of gear 1 will be equal to the force of gear 2. Using that above equation there, we get the torque of 1 over the radius of 1 is equal to the torque of 2 over the radius of 2. Rearranged, we have T1 over T2 equals R1 over R2. These radiuses in proportion to each other are equal to the tooth ratio, so it's teeth of 1 over teeth of 2, or our gear ratio. So torque 1 over torque 2 is equal to, let's say it's our 3 to 1 still, so it's 3 to 1. Moving T2 over to this side, you get the torque of 1 is 3 times greater than the torque of 2. So if you rotate the 1 gear at 1 Newton meter of torque, T2, sorry, that's T1. T2 is going to be equal to 3 Newton meters. And just like the speed law, this would work in reverse. So you could go from 3 Newton meters down to 1 Newton meters. So the overall benefits of using gears and gear ratios is you can go up or down in speed, and you can go up or down in your torque. Thank you for watching.